From Microbe TV, this is Office Hours for Wednesday, Wednesday, December 20th, 2023. I'm Vincent Racaniello, and welcome to the place on the internet, the little live stream where you can ask me about viruses, you can ask me about teaching virology, you can ask me about doing podcasts and all the different subjects that we do at Microbe TV. Anything goes. And if you notice these little lights in my eye, that's because I have this cool thing right in front of me. It's it's basically it's sold as a terrarium. You put dirt in it, and you put plants in it. It's got a little door here, the door. But I put lights in it because, of course, it's an icosahedron. You can see the triangular faces. You know how many triangular faces there are in an icosahedron? All right, I'll wait to see who knows. And I just wanted to show you that because it's on today's image for the live stream today. I think this is a cool little thing. It can actually, let's see, it can flash. What else can it do? It can go slow on and off. And I like it just on like that. So let's see. We'll put it off to the side so it doesn't reflect in my glasses. Okie dokie. All right, tonight we got no flies and we're pretty much recovered. I still have a little, that nonsense? Because rhinoviruses take over a week to get the hell out of you. But I'm much better than I was last week. Thank you all for your wishes for recovery. I have recovered for the most part. I have recovered. I got my energy back. I got my mojo back. I am ready to do proper office hours without sniffling and coughing and complaining and asking you about how to blow my nose without hurting my nose. Okay. So here we are. It's me. Sorry, it's just me. Maybe next week I get someone. I just don't know. But I have some things I want to talk about tonight. I have one thing I want to talk about. You guys are going to drive the rest. But tell me where you're from. I have 100 people here right now. And love to hear where you're from. So, by the way, it's the holiday season. It's the giving season. End of the year. Many people like to give because they get their tax deduction. And, of course, Microbe TV is a 501(c), which means your contributions are U.S. federal tax deductible. But even more interestingly, you see up here, parasiteswithoutborders.com. That's Daniel's website. Parasites Without Borders is a 501(c) also. And he's doing a matching fundraising for Microbe TV the months of what? November, December, January, I think. So if you donate something to him, he will match it. Not mash. He will match it and give us. So if you give him $100, he'll add 100 and give us 200. So please, that's the best way to get your buck. There's a button on the front page of parasiteswithoutborders.com where you can do that. Normally, I would say just go to Microbe TV. We now have a button on the front page of Microbe TV. Have you seen it? But for these months, go to Parasites Without Borders because that gives you a doubling of your donation. It's really very useful. Okay. All right. Yeah, I can see those dots there. Maybe I'll just turn it off. Right? What's the point? I don't need to have Christmas lights or icosahedral lights. Let's see where people are from here. Oh, so first of all, our moderators are all here. I have seen Les. I have seen Vanity. I have seen Tom. I have seen, let's see, who else? I'm pretty sure I saw Steph. Is that true? Did I see Steph? I'm scrolling down. Okay, I haven't seen Steph yet. Maybe she'll pop up later. Maybe not. Oh, there she is. I'm back. Yeah. Energy abounding. Feeling much better. You know, it's interesting how just a little cold, a little rhinovirus can make you feel so crappy. Much better now. Thanks all of you for moderating. It's really appreciated. Now, let's see where people are from. All right, so Lise is from Columbus, Ohio, which is where ASV will be next year, the American Society for Virology. And I will be there doing a TWIV with at least Kathy Spindler and Rich Condit, probably Brianne Barker. Those are the people who usually go, and we'll have a guest. It'll be fun. And I understand that we can go out with some of the local folks. That would be fun. Be happy to do that. Okay, so Lisa's from Columbus. Neva's from Buda. Cool. Just had lunch with the Condits a few days ago. That's cool. Oh, Tom. Sorry, Andrew. Sorry, I forgot Andrew, our moderator. Thank you very much for all of your help. Frank is here too. I missed a lot of people. Jan is in San Diego this evening. Andrew, of course, is in New Zealand. Hey, Kang is from Chicago, where we met not too long ago when we were there for ASTMH. That was fun. Richard is from Portland, Oregon. I remember Lavis from last time. Is from Colombia, South America. And I was thinking, I couldn't remember if we ever had someone from Colombia. Maybe, but not in a while, maybe. Peter is from Boulder, Colorado. Noir is from Santa Fe, New Mexico. I know that. Some people I already learned where they're from. Pete is from a mild but dreary London. London is a place where I'd like to spend the holidays. Yeah, that would be fun. Let's get the hell out of here. Nicola is in Italy tonight. Very good. Ooh, look, Dagfinn is from Bodo in northern Norway. Now, I guess I mentioned that I met some people from Norway at the giant virus meeting. Yeah, I do sound better. Thank you, Tona. I feel much better and I sound much better. Yep. Oh, Frankfurt. Cool. I just flew in and out of Frankfurt 2 weeks ago. It's cool. Patricia is from Chile, Cape Cod. "20 faces. 5. Faces, which each face is an equilateral triangle. Very good. Good job, Nicola. 20. 20. Very good. Doreen also got it. MK also got it. Les. No. Frank. 19. No. 20. Pete got 20. Oh, a lot of you responded. I'm sorry, I missed all that. I guess I'm like, what do these numbers mean? Yeah, Vincent, you asked them. Jessica is from Tomball, Texas, right? Am I getting that right? Let me know. Visto, where are you from, Visto? I forgot. Silvio Pina, thank you for your contribution. Thank you so much. Endless gratitude to Vincent for the enlightening journey with Microbe TV. TWIV is unparalleled. Thrilled to support and excited for the incubator visit. Yeah, Silvio Pina's visiting on the 28th, I believe. It's a Friday. I'm looking forward to it. We're going to go get sandwiches downstairs. I want to see where everyone's from. I know that the Team Doreen is in the Chicago area. Yeah, for sure. Happy solstice in 2.5 hours. That's right, the 21st. Yes. Rumson, New Jersey. No, what are you doing in Rumson? You don't live there, unless you moved, because I know you were somewhere else. Hans is from Ecuador. Rainy's from Eastern North Carolina. Doreen is from Central Connecticut. We got 2 Doreens. See, we have this one, Chicago Doreen and Mr. Doreen. Then we have this Central Connecticut Doreen. But the funny thing is they have the same icon. Isn't that funny? Okay. Peter S. is from Boulder, Colorado. Frank is from north of New York City. Nebby is from Lake Wales, Florida. Ron is from Galveston, Texas. Oh, Toledo, Ohio. There's someone else from Tomball, Texas, who I confused with you, Jessica. So, yeah, sorry. Toledo, Ohio. And you're going to come to ASV next year for sure. Orange County, New York. Los Angeles. El pueblo de Nuestra Señora la Reina de Los Angeles del Rio Porciuncula. I can't say that one. Los Angeles. That's pretty funny. JT is from New Mexico, the land of enchantment. School email is from Ithaca, New York. Oh, look at Cam, Mr. Ozzy Cam. Mr. Ozzy Cam used to be here a long time ago. I was just thinking today I should tell everyone when we started this stream, it was sometime during the pandemic, but 2020 maybe. It was called Q&A with A&V. Started with Amy. And we've been going strong ever since, a couple of years. Yeah. Okay, welcome back, Cam Research. Patty is in Massachusetts. Sam is in Ottawa. Noir is in Santa Fe, of course. Wow, it's warm there. Silvio Pino's in Burbank at the moment. It was originally from Bologna. Artemis is in Montreal. We met Artemis when we were there for a TWIV. Betty is in Fort Collins. Wayne is in Urbana. Fred is in Queens, not too far from here. Andrew is in Australia. Characters that I cannot pronounce are from Singapore. Doreen is in Elgin, Illinois. Tona, is that where you're from? Lawn Guiland? Okay. Questella, I know, is from Ohio. Questella was actually at the first Q&A that we started. She's been here from the start. She said it was going to be successful, and she was right. She said, you're going to get 100,000 YouTube followers, and she was right. So when Questella pronounces something, you got to believe it. Steve is from LaGrange Park, Illinois. Oh, so this is spelled out phonetically. Huh? Let's go back to the thing I didn't know what it was. And apparently it's something spelled out phonetically. And now I can't find it. And I'm going to lose my place. See, Tona said, I've never seen anyone spell it out New York phonetically like that. So the thing I said, where you're from, here, Long Island. Ah, Long Island, of course. Dumb Vincent. Long Island. Okay, you win today, Tona. Markle, east end of Long Island. Chris is in Montreal, Canada. Long Island. Margot is in Phoenix, Arizona. They say, there you go. Levis is in Colombia. Levis Marugo Castañeda. Is there anyone else from Colombia? I don't think so. I don't know if there's any. Well, I know there are people from Brazil here sometimes. So South America is represented. Yeah. Jefferson Space is in Miami. And people are saying, oh, I'm not too far from you, right? How about a tridecahedron? It doesn't work for viruses, no. I don't know about luck. Oh, so Vanity, I hope you feel better. RSV, yeah, well, you know, there's not much they're going to do for you except say, yeah, you have RSV. But I did get the RSV vaccine over a month ago. Yeah. Anyway, feel better. Oh, so you're originally from Rumson, but currently on Long Island. I didn't know that. Evan is from Allentown, PA, and you were at TWIV 1000. I do remember. Sorry about the throat clearing, folks. It's mostly from just having eaten. I find that when I eat, it does something that makes you want to clear your throat for a while. Bernard is in Alexandria, Virginia. Jordy is in Montreal, Quebec. Let's see who else. Barbara is in Buffalo, formerly Ithaca, sticking around upstate in New York. I watched in 2020, then missed you this last year. Yeah, a lot of people have stopped listening. It's okay. I don't mind. You know, people who come want to be here. How's Amy? Amy's doing well. Yep. Oh, Lavis, thank you so much for your contribution to science communication at Microbe TV. Very much appreciated. Thank you so much. Okay, I think, oh, here we go. Brazil. Bully is in Brazil. So 2 people. Yeah, this is not good. Sorry, I just see that. There's no Paul. I have a double scene. I shouldn't really have a double scene on, but it's fine. Thank you, Richard, for pointing that out. Appreciate it. Ziziva 303 is from Denver. Oh, Stephen Lurie from Paso Robles. Great red wine. Really nice red wine in Paso. Sue is lurking from Tucson. Tested positive for COVID 4 days after husband got it. It's that time of year. Everybody's got something. I mean, I had 2 consecutive rhinovirus infections. Pfft. Not fun. Oh, hello, Amy. Look who's here. Amy's saying hello to you, Doreen. I don't think I've ever seen Amy on the stream like that. Tom thinks it's cool that AR showed up. Here, Amy, we miss you terribly. Hi, Amy. Hi, Amy. Nice cameo. Everybody's saying hello to you. That's very cute. All right. That's where everyone's from. Welcome, Amy. If I say something wrong, correct me. Everybody's now recognized that you're here. They're all excited to see you. Look at this. Amy. I'm sure you can see it in the comments, Amy. Look. Watch. Amy, go look at the stream. I'm sure you're looking at it. They're all saying hi to you. So this series, this live stream began as Q&A with A&V, Amy and Vincent, and then it morphed into office hours. And, here's Amy. Remember this? Amy Virologist. One of our moderators, Barb Mac UK, had this made for Amy. It's got all the signature stuff, like the princess shoes and the lab coat and the name, plaque assay, the princess stuff, the prince of plaque assays. So there you go, Amy Virologist. Yes. Amy says, I see. Everyone's very happy to see you. Okie dokie. I wanted to, before we get into your questions, I wanted to talk a little bit about VZV, Varicella zoster. What do you think about that? Well, it doesn't matter what you think because I'm going to do it anyway. People have been talking a lot about it lately, so I put together a little presentation, and we're going to talk about it. Here we go. Screen share. Varicella zoster virus. It is a virus that causes two diseases. It causes varicella, which is chickenpox, and zoster, which is shingles. Okay, one virus does both. How does that work? Okay. Amy wants you to know that the Amy Virologist is framed and in her office. Okay, so when we talk about viruses, we typically talk about either acute or persistent infections. Here's an example of an acute infection. This is on the x-axis is time, and then on the y-axis is either virus production in the blue line or disease in the red. So an acute infection is rapid and self-limiting. Comes and goes, it's over. You either die or you recover. Whereas a persistent infection is long-term and, in fact, lasts for the life of the host. So think HIV, AIDS, you're infected. You are infected for your life. You're not getting rid of it with current technology. Herpes simplex virus. You're infected for life. Unlike love, herpes is forever. And these kind of persistent infections, they're characteristic for each viruses, and they probably also begin as an acute infection that's never cleared. So some examples of persistent infections. So we have our acute infection here on the top. And again, we're looking at virus production on the y-axis, time on the x. And below, these three panels are typical persistent infections, again, that last the lifetime of the host. We have a latent infection in the form of herpes simplex viruses, where you're infected, the virus remains in you forever. And then you have periodic episodes of virus, sometimes with disease in the form of a cold sore, sometimes not. There are other viruses that reproduce continuously in you. JC virus is a polyoma virus that does this. Once you're infected early in life, it continues to reproduce in many organs and often without any pathogenic consequences. Okay? Then we have persistent pathogenic virus infections like HIV-1, where you have an initial acute infection, then a long period of virus reproduction, usually with some kind of disease. And then at the very end, you have progression to AIDS and death if you're not treated. So those are acute and persistent infections. So here's the varicella zoster virus. It is a herpes virus. There are a number of different herpes viruses, including herpes simplex 1 and 2, Epstein-Barr virus, cytomegalovirus, varicella zoster, and human herpes viruses 6 and 7. Those are the human ones. Envelope viruses with a couple of different kinds of spike protein in the envelope. And within the envelope is an icosahedral DNA shell containing the double-stranded viral DNA. It's a linear double-stranded DNA molecule. It's quite large, certainly over 150 kilobases of double-stranded DNA. All right, so that's VZV. Initially, as a child, you are infected with the virus. It's typically via the upper respiratory tract. The virus reproduces in local lymph nodes in the upper tract, establishes a viremia, which brings the virus to other organs like liver, spleen, etc. It reproduces there and makes a secondary viremia, and that brings the virus to the skin. And here in the upper right is your typical chicken pox. So you have a rash, and then at the same time that you see the rash, the virus is going into sensory ganglia. Ganglia are collections of neurons outside of the central nervous system. And there the virus remains for your lifetime. And in most cases, when you are over 50, you get reactivation and you get a rash, which is called shingles or herpes zoster. And here's an example on the belly of a rash of someone with shingles. I had this when I was 50. In fact, the first year of TWIV, I had shingles. I had chickenpox as a kid because when I was a kid, there was no chickenpox vaccine. Okay, so we don't know what the factors are that reactivate, that lead to this, but the rash pattern is very specific. It's in a specific dermatome, which is a part of you that's innervated by a particular sensory ganglia. So let me show you what the dermatomes are. We have a lot of different dermatomes, and there's some on our neck, our chest, as you can see here, arms, legs, back. So if you got a reactivation of zoster, it would be in a specific dermatome, say T5, T6, but not T5 and L5. The virus, for some reason, goes to one set of sensory ganglia, and they get reactivated from there. So that's what I mean by a dermatome, the part of you that's innervated by sensory ganglia. Okay. So zoster is obviously an age-dependent phenomenon. Here's a graph of the age-specific incidence of herpes zoster worldwide. So this is in a variety of different countries, as you can see here. And on the x-axis is age, and on the y-axis we have the annual incidence, 1,000 person years. So you can see there is some at young ages, but not much. But then at 50, it really goes up substantially. So this is why we recommend, if you have had chickenpox as a kid and didn't get vaccinated, that you get a shingles vaccine. So here's a little summary of what we know, that before the vaccine was developed, 99% of adults were infected and developed chickenpox. Of those, 30% developed zoster, and most of them over 50 years of age. The viral DNA is episomal, which means it's in the cell nucleus of these ganglia, and it's apart from the chromosome. And there are 2 to 9 genomes in 1 to 7% of neurons. So not all the neurons in a ganglia, and it doesn't replicate because neurons don't replicate. A few viral genes are expressed, and as I said, the factors that trigger reactivation, we just don't know. Now, what about vaccines? This is my last here. So the first vaccine to be developed for chickenpox, varicella, was called the Oka vaccine. It's developed in Japan. It's an infectious attenuated vaccine, so it reproduces in you. It was first developed for immunocompromised kids who developed extremely severe varicella. and often life-threatening. So this vaccine was made for them because they had the highest morbidity and mortality from chickenpox. And then in the 90s, it was spread. It was used in other kids, immunocompetent kids, because it's a good vaccine. It works well, and the idea was that there's a sufficient amount of morbidity and mortality from chickenpox that it's worthwhile to vaccinate kids. All right, so this is currently the vaccine that's used for kids. The problem with it is that it's infectious, so it can integrate into a nerve ganglia and it can reactivate. It's much rarer than natural infection, but it does occur. And this is a graph of the effect of vaccination on varicella-related mortality rates by age group and year in the U.S. We have less than 20, less than 50, and greater than 50. And you can see from 1990, there was deaths per 1 million population. It's very rare, but that rate went way down after vaccination. So the vaccine prevents death. Now we have a herpes zoster vaccine, right? We have Shingrix, which is the glycoprotein, one of the glycoproteins on the virus particle. It's called GE. It's produced, purified, and mixed with an adjuvant. This is a great vaccine because it's almost 100% effective at preventing zoster, preventing shingles. And so everyone over 50 should get that. I just got it, I think last year. A bit late for me, but better late than never. I mean, I'd already had shingles, but this would prevent it from happening again, which can happen. Now, my understanding is that Shingrix is going to be tried for kids, in which case it would be one vaccine for both. Previously, the OCA vaccine was used as a zoster vaccine. It was about 14 times higher dose was given to adults, but it was the exact same vaccine that was given to kids. But Shingrix is way better, and that's why it's replaced it. Okay, so that's a little spiel on what? Herpes zoster, everything you wanted to know. So if you're over 50, you should get the Shingrix. It's a really good vaccine. It is safe. There's some side effects, pain at the injection site, fever. It's okay. It's worth it because zoster can be painful and can have serious consequences, okay? All right, so let's see what people have got on their minds here. I think I saw a question early on. Let us see. Of course, you can ask about that stuff too. I'm happy to talk about that. Okay, Kang says, what factors determine whether viruses involved in pandemics become either endemic like SARS-CoV-2 or disappear like 1918 flu? Well, that's an interesting question. So 1918 didn't actually disappear, right? It just... So it went into pigs, and it remained in pigs, and it's still there. All right? It has drifted very little. It's undergone recombination, reassortment, but the original 1918 flu is still in pigs, and that gave rise to the 2009 pandemic because that virus hasn't changed much over the years in pigs. And then in people, the 1918 continued to circulate and eventually underwent antigenic variation, right? From 1918 to 1957, the virus changed every year. And then in 1957, we had a reassortment event that gave us an H2N2 virus. Remember, 1918 was H1N1. So 1957, we have a reassortment event. We now have H2N2, and in people, then the 1918 virus disappears. However, the internal genes of the 1957 virus came from 1918. So if you go back to the Jeff Taubenberger interview I did 2 years ago, he says basically all contemporary influenza virus strains in humans originated from that 1918 strain. So it really hasn't disappeared. It's just done different things, right? So SARS-CoV-2 is here to stay because it's infecting many different animals besides humans, so we really can't get rid of it. And there's so many asymptomatic infections that we couldn't get rid of it. So it's here to stay. And it's changing a lot, right? It's undergoing antigenic variation, and presumably that's going to happen for the foreseeable future. So I don't really see that there's a big difference. Both are undergoing variation. One is by mainly mutation, SARS-CoV-2, a little bit of recombination, and then influenza virus, mutation, and now and then reassortment. Yeah, that's how I view it. Did you like that little mini lecture? Yes. I like that. I think it's useful and gives you a little snippet of information to get us started here. I'm scrolling, looking for questions. So let's see. Frank tested positive. So he's got COVID, mild fever, now nasally congested. So that's probably as bad as it's going to get. And you'll recover because you've got multiple vaccinations, I presume. So, and you're also young, so you're going to be good. Yeah. Great. How do we know if someone is SARS positive on a rapid antigen test at day 14, since beginning of symptoms is still contagious but doesn't feel sick anymore? Well, we can't know on an individual basis, right? But we can make conclusions based on observations that we've made in a lot of people. So, day 14, forget about it. No virus shedding of any consequence is likely happening on day 14. You're positive on a rat. Okay, there's some viral proteins hanging around and maybe a few PFU, but I doubt it. If you look at studies that look for culture positivity, which means you take a little swab, you put it in culture, and you ask, do the cells die from a virus infection? You might see something, but we don't know how much virus is there and whether it constitutes a threat to others. So there may be a little infectivity, but by day 14, I think you can assume that it's over. The shedding is over. It's over day 5-ish, in my opinion, in terms of threat to transmission to another person. So I don't care that it's rat positive. I think that just can happen by having some pieces of protein around and not enough virus, if any, to transmit. Okay, Susan? Day 14. I think it's conservatively day 10, but I think that's even farther from reality. I think day 5 to 7 is plenty for not transmitting. And if you're worried, you could always wear a mask. By the way, since I got 2 miserable rhinovirus infections in the past month and a half, I'm not wearing a mask on the train. I don't want to get another one. It's miserable. I sit here and be miserable to you guys, and I feel miserable. It saps my energy. No. So I'm wearing a mask. You know what the funny thing is? Someone sat next to me on the train, and I put my mask on, and then they left. It's a good way to have a seat by yourself. How about that? And this was a lady who traditionally would be wearing a mask, and she just left when she saw I put the mask. The mask is to protect me. It's not because I have something, okay? It's really funny. Okay, on to other questions. Everybody's talking about their vaccines, their illnesses. Okay, Pete says, do the 4 old coronaviruses have worse or similar symptoms to rhinovirus infections? They can't. It varies, right? Some of them are what we call common cold-like, which is what I had. Upper tract, congestion, cough, sneeze, typically no fever. The coronas can do that, but they can also cause more serious respiratory disease, and as Amy will tell you, the rhinoviruses can do that as well. Okay, so that's the story there. A group from here should plan a holiday trip to London in November or December. Yeah, that's a cool... I like London a lot because, well, first of all, everybody speaks English, so it's easy to get along, although it's just a fun town. I like it a lot. I mean, but Rome is cool, too. What's a good... Berlin. That would be cool. Paris would be cool. Madrid. The European cities are all cool. The old European cities are great. But, we talked about TWIV cruises, right? That would be fun to take a TWIV trip or a microbe TV trip to a city and somehow, focus it on science. Like if we went to Paris, we could go to the Pasteur Institute. Oh, it was so cool, right? Let's see. What else? Oh, here, Paul wants to know, what is a good suggestion you can give to a postdoc? Workload can be overwhelming. Is it necessary for success? Other aspects you can suggest to be successful in academia. Oh my gosh, before I answer, we interviewed on Immune yesterday a lady who said she did this amazing immune dictionary where she injected mice individually with each of 86 cytokines and then removed lymph nodes and did single-cell seq to find out the gene response to each cytokine. So you figure it at 86 cytokines times 17 different kinds of immune cells. She said she would start the experiment at 11 p.m. and then do the injection at 2 a.m. Oh, my God. She was a postdoc when she did this. So, there's some projects that need pretty grueling work. And that's just the nature of science. You really can't get around it. I mean, not all projects you have to work overnight. But I found that working hard was important. Why? Not because it's a badge on its own, but experiments don't stop when you feel like stopping, right? Many of them go on for days and you have to keep doing it. So there are a number of things you can do. You can try and do the kind of project where it's a little less crazy, but you're going to limit yourself as to what you can do. I think you need to work as much as you need to and just balance it with something that relaxes you, right? Some people don't need relaxation. I know one person who's here tonight who doesn't need any relaxation. She can work all the time. But other people do in various forms. So I would say just make sure you give yourself that. So you give yourself a break so that you can work hard for some period of time and then take some time off to chill in whatever way you want. And so I think for Yeah, I think you're going to have to do that. Otherwise, you'll get overwhelmed. I totally agree. Now, is it necessary for success to work hard? I certainly know successful people who worked 9 to 5, right, and not on weekends. So it depends. It really depends on the person. I mean, this person I'm thinking of was very talented and efficient, but not everybody's efficient. So you can't get everything done on time. What's important for success is to have a good project and to do well, get good results, and publish it in a good journal. That's important. If you don't do that, then it's going to be harder. And of course, it also depends on what your metric for success is, right? Is it an academic job? Is it an industry job? Is it something else, right? So you have to decide what you want and then do what's necessary to achieve that. And in the process, have some balance. That's my advice. I liked to work hard. It was fun, and I still do. And I used to give advice, which I think someone gave to me. I just don't remember. I said, make sacrifices now for choices in the future. So think about that. Okay, Abilash says, it would be great if you have Stephen Russell, Grant McFadden, John Bell, or Richard Vial to talk about the future of oncolytic viruses. So we have had, I think, Stephen Russell. We've had Grant McFadden for sure. We had early on the CEO of I think it was Reolytics. I don't remember. On TWIV. It's the CEO of the company, and he was good. We've also had Grant McFadden on. But I agree, it would be worthwhile to revisit some of these with more contemporary approaches because things have changed. So, yes, we can do that. Let me write it down. I'm pretty sure we had Stephen Russell, but McFadden, John Bell, Richard Vial. All right. Thank you. Artemis writes, we know which influenza strains are circulating now. We also know which strains are used for this year's vaccine. Why is this not enough to know the influenza vaccine's efficacy for this year? Well, it is enough to know, but we have to collect data, right? So the vaccines are given to people starting in, say, August, and they continue to get them through December. And then you want to see how the flu season runs from, November through May or April or March, and look at the whole picture, right? Not just 1 month, because from year to year, the kinetics of flu varies. Some year you have quicker onset, earlier months. Some years you have a later month. Cases are more some years than others. So you want to have the whole year's picture in before you say, what did it look like and how did the vaccine impact it? So we can know. We just want to wait until we get all the data, right? Makes sense? How come we have rapid COVID tests, but not rapid flu or rapid RSV or rapid rhino? Well, of course, we have tests for those, but they're not in a rapid format that's consumer friendly. Why not? Well, this is actually something that Amy used to talk about all the time. So we said we don't test for any of these other viruses. Why are we testing for SARS-CoV-2? And now, of course, we're testing less and less. But you could argue that you should test for flu because you could pass it on to someone who's vulnerable, right? If you're going to test for SARS-CoV-2 and make a behavioral change based on the test, then you should test for other viruses. For sure flu, for sure RSV. Amy would argue rhino because it can be severe as well. And then you have to decide how's this going to inform public health policy, right? If everyone had access to rapid tests for all of these, what would you do with the results? Say if you're positive for any of them, do you stay home? I don't know. This is something that would have to be discussed. You could stay home for how long? Or could you wear a mask? I just don't know. Because you can imagine that it would be quite disruptive, as COVID was, right? Incredibly disruptive. Although I would argue that if you had, rapid antigen tests you could do really cheaply on a daily basis, the minute thing, that could change the face of a pandemic and not require complete shutdown, but just selective removal of people from the school and the workforce, right? So I think it's an interesting concept, right? But how you use the data needs to be discussed. But I think, in 1890 is saying stay home if you're sick, folk. I think that's a good plan. But sick with what? With everything? You don't know what you have. That's the problem. The only thing you know nowadays is SARS-CoV-2. So I think we have to do a little reckoning with our public health policy post-COVID. Wayne got the RSV vaccine. His health insurance left him with a $57 copay. The bane of copays. Yep. Everything is slightly different. Unfortunately. We used a new to us test for flu and COVID with lights coming on that show positive or negative. So a dual test, yeah. That's cool. Lise was in a class with our former Columbus health director, and she is interested in microbe TV. She should be interested. It's a valuable resource. We make great science content. It's a little complicated, I know, but we could fix that. We just need help, financial help, right? Pete has an anecdote. Came back from Egypt. Tired, sniffle, throat tickle due to visit mom in hospital. Faint line on old LFT. Brought fresh LFTs. Positive for 3 days. Barely symptomatic. Last time, March 20. Boosted. Okay. How do I know they were rhinoviruses? I didn't test. The symptoms were consistent with rhinoviruses. It wasn't COVID because it was negative. It didn't seem severe enough for RSV, although, of course, you could have a mild RSV infection. Flu, I don't think so. It didn't have the substernal involvement that you usually have with influenza. So, Daniel threw out rhino because at the time he was seeing a lot of rhino in his practice. And whether or not Amy agreed, I'm not sure. Oh, Sue attended a super spreader Christmas party last Tuesday. Excellent. I presume that I got the second bout of whatever I had. Let's call it rhino for simplicity. During my travels in Germany, right? I'd just gotten better from the first one, I think, during the German trip. So maybe, at the meeting with a lot of people. I remember I got home Sunday, and then Monday I started to have sore throat. So probably not the airplane, probably before that. Michael tried to stop listening to, office hours, but I'm addicted to science and try and make myself smarter. I love it. I love that that view of science is what makes us healthy. I mean, the stuff science does is amazing. And then you have people trashing it like, well, you'll see on Paul Offit's latest Beyond the Noise, which I hope to release tomorrow. Is there anything new with the latest SARS-CoV-2 variant, which, of course, the press is calling a scariant? I have news for you, folks. None of the variants were scariants. They were just variants. They caused COVID. They were more fit than their predecessors, so they displaced it. And then with Omicron, there were some substantial immune evasions. There's no evidence that any of them were scarier than any other, that any of them were more pathogenic than any other or less pathogenic. None whatsoever. We know this now because the right experiments have been done. And the press now still, this virus is barely out there. And they're making conclusions that cannot be made at this early point in time. So there's nothing new. It's got some changes. It's a derivative of previous Omicrons. If you're vaccinated, you're going to be protected against severe disease and death. No problem. I miss guessing which color sweaters A and V would be wearing each Wednesday. Yeah, you remember that? Now there's no question now. I'm always in black. I've changed my wardrobe. I wear black turtlenecks now. That's it. No more Oxford button-downs. That phase is gone. Why? Because actually they're cozy. I mean, maybe in the summer I'll feel differently, but they're cozy. And then tonight I have a black jacket on because it's a bit chilly down here. But at least there are no flies. Silver lining. But yes, I do remember the guessing as to the sweaters. Some people won. I've been seeing some graphs showing JN4 is growing even faster than 1. What do we know about 4? Well, we barely know anything about 1 in terms of antigenic characterization. But, these fitness advantages that these variants have, they're rarely figured out. Nobody bothers to do the kind of experiments in the lab where you figure out. And it's really hard to do because we're talking about fitness advantages in a human population. So how are you going to reproduce that in a culture dish, even in an animal model, which is never perfect? So I think it's very, very difficult to understand what the fitness differences are. For influenza virus, Ron Fouché always says the fitness advantages are all about antigenic evasion, immune evasion. It's not clear whether that's the case. So in other words, JN4 is growing faster. It's, we have to see in the world's population how that plays out, but it has even better fitness, which to me is really interesting that you can make variant after variant that can displace the previous one. That's cool. Very interesting. And I'd love to know what's happening, but we don't know. People don't do the experiments. Wow, we exceeded 200 people tonight. I'm very impressed, folks. I figured the holiday week, maybe next week will be sparse, but I plan to be here next Wednesday, which is the 27th of December. I'll be here for office hours. Who can I get? Would be on short notice, would be a fun guest. To think of someone. Artemis says chickenpox is called Varicella in French and shingles is called zona. Cool. Yeah, you never heard that one? Unlike love, herpes is forever. I say it every year. Multiple times a year. Yeah. I say it multiple times a year. Do bacteria also have the same patterns of infection as virus? Now, what do you mean the same pattern of infection? You know, there's the bacteria gets in you. There's an incubation period. There's a period of shedding, and you can transmit to others. There are respiratory bacteria as well that can be in respiratory droplets. I tend to be longer if I were to generalize anything, but it's really very similar, right? It's a pathogen entering a host and reproducing, and in many cases causing disease. Now that's an oversimplification, and I'm not a microbiologist. Oh, I am, but I don't study bacteria. But Michael Schmidt, maybe I should get him on next week. He would know. Yeah, we have 135 likes. Hit the like button, folks. There's over 200 of you. It'd be nice to get 200 likes. Why is that interesting? Well, because... Why is it desirable, not interesting? Because it potentially can attract people. If a show is getting a lot of likes, it can potentially attract people. And I don't need numbers per se. I just need to teach more people, okay? So if I say to you, I want 1 million YouTube subscriptions, it's not because to feed my ego, okay? It's because I want to teach 1 million people. At lunch one day at the giant virus meeting, a table full of young people, I said, please go to YouTube and subscribe. And one lady said, why should I give you my subscription? And I said, well, I want to teach as many people as possible. I think education should be free. She said, okay, you sold me. It's not because I want ad revenue. No. I mean, it's nice to have a lot of subs, but it's more nice to have the world to teach. And that's what I want. Okay. Dagfin says, I've seen a few cases of autoimmune diabetes type 1 following chickenpox in young patients. Do we know the mechanism? No, I do not. I do not. Let's have a look. VZV. Hey, I've not even heard it. I don't know what the mechanism would be, but I mean, one possibility is that you make an immune response to the virus, and there's some cross-reactivity with, cells that are in the pancreas, for example. But I don't know. What's the deal with BK virus and transplantation? Well, everybody has BK pretty much. Let's see. BK. Healthy adult population, BK seroprevalence is around 90%. So, yeah, you can. So what if someone has BK? What are you going to do? You're going to still go ahead with the transplant. Then you have to deal with the BK infection, right? Which could get worse or become pathogenic after immunosuppression, right? So BK causes a progressive kidney transplant injury in 1 to 10% of renal transplant recipients. Early treatment is beneficial for screening, and early treatment is beneficial. So, yes, we should do more screening. I'm surprised if we don't, because transplant patients, they're at risk for a lot of these persistent viruses. So BK is one of the many polyomas that's persistent in most of us, right? Along with herpes viruses and many other viruses. And so they're a particular issue in transplant patients. Do bacteria produce antiviral substances? They certainly produce substances that inhibit bacteriophages. Yeah, there's all kinds of mechanisms that bacteria use to counter bacteriophage infection. Yeah. In fact, we talked a little bit about it on the last TWIV with Jolene Ramsey. Willis had shingles at aged 35. Yeah, so it's not non-existent. But even if you've had it, you should get vaccinated. Given that incidence graph, wouldn't it be better to vaccinate at 40 rather than 50? Well, look, I mean, the real bump is between 40 and 50, right? But it keeps going up. I don't know. It's a good question. I don't know what, this is obviously one set of data, and they may have based the immunization decision on another set. But you would like to stop that increase, right? That would make sense, Nicola. Yeah. At what level does antibody protect against rabies? Well, it doesn't protect against infection, right? Because you get bitten, say, by a rabid animal, so you have virus in you. It's beginning to reproduce at the bite site, and then you can get immunized, and that prevents you from developing rabies. So it sounds to me like the antibody or the T cells or both are somehow involved with preventing CNS invasion. And so when you think about polio vaccines, they reduce the level of viremia so that you have a less chance of virus getting into the CNS. So I just think for polio, it's a random event where you have a lot of virus in the blood. It's just increasing the chance that it's going to get into the central nervous system. And maybe that's the same with rabies. I'm guessing, because I don't know. Patricia says, we had a patient with stroke and shingles after stroke. His shingles rash was old but persistent with flares. We wondered what nerve damage from the stroke may have contributed to the flare. Yeah, well, I think it's a stress, right? That likely participated in the induction of shingles, for sure. We don't know what the stresses are, but stroke is one, and I'm not surprised if that would do it, because it's associated with inflammation. Yeah. Where did Zostavax fit in there? I think Zostavax was, this is the original, excuse me, it was the name of the high-dose OKA vaccine. So OKA was the childhood chickenpox vaccine. A high-dose version was given to people over 50 for shingles. That was Zostavax. That's no longer used in the U.S. Shingrix is way better. Frank says, do you have much hope that oncolytic viruses will eventually be approved as a cure for some cancers? I do. I've always had high hopes because I've watched the field mature over the years. You know, I've taught it in my course for many years, and I think some of the developments are really interesting. And I suspect that for certain cancers, they can be useful. And maybe even replace current therapy. So I do. Not everyone shares that, but I do. Hans says, Vincent, we know an infection occurs when a virus enters a cell. But when can we tell there's an infection due to an extracellular parasite, such as most bacteria and parasites? I don't know what the question is. When can we tell? So here, for example, the last TWIP. This fella had a worm in his eye, right? Which happened when he got bitten by a deer fly who deposited the ova into him, and they matured into microfilaria, which are in the blood. And you could take blood and look for them. So there are many parasites with extracellular phases that you can detect in the blood, in other kinds of sites, in anatomical sites or fluids as well, right? So that's how you would detect if you have an extracellular parasite, yeah. Do we have a Shingrix-like vaccine for HSV1 or 2? We do not. That people have tried for many years to do that. I'm not sure that Shingrix approach is going to work exactly for herpes, but there's certainly some in trial. You know, a lot of people would like to have them, but they're not there yet. And as I said, yes, 1918 flu is still here. And Lise got her Shingrix due to people nudging her here. So this is a good community if you want to listen to people nudge you to get vaccinated in certain ways. This is the place to come. Should I do this? Oh, yeah, you should. JT is immune compromised, afraid to get the vaccine. Never had shingles. Afraid to get the vaccine. Well, it is it's not an infectious vaccine. It's just a protein. And I don't think it's an issue with you being immune compromised. I mean, you may not make a great immune response to it, but you could look in trials to see if they've looked in immunocompromised patients or talk to your doctor. But I don't think per se, if it were an infectious vaccine, then I could see your concern. But it's not. It's just protein, right? Professor Special K. I think I just did that. Yeah. Yeah, there's no yet herpes-like vaccine. Yeah. If one is having an unidentified viral respiratory infection and spend a whole day in a room, then left, how long would you suggest visitor avoid entering that room to avoid infection? So you have two things there. You have fomite and infection, right? So fomite could be you touching something and then contaminating yourself. So that would have to be a virus that will retain infectivity on fomites. And you know, uh, SARS-CoV-2 doesn't do that for the most part. So it's all the virus in the air. So it's a matter of how long it takes for the droplets to settle to the ground and no longer be an issue. Now, it also depends on the circulation in that room. If the circulation is really good and you're sucking out the air and changing it X times an hour or whatever, then it's less time. But let's say it's a completely uncirculated room and you got a person who's been breathing there all day. You know, within a couple of hours, the droplets are all on the ground. There's nothing keeping them suspended. So overnight, 12 hours is totally sufficient. Can viruses come back as ice melts? They could. You know, people have recovered some viruses from Siberian permafrost, right? So the question is, so they take the ice and they thaw it, and in the laboratory they put it in amoeba. And they can get the viruses infecting the amoeba. So the question is, could those, as this melts, is the water going to come flowing out with viruses in them and make an aerosol and we're going to inhale them? It's possible. I cannot tell you no, it would not happen. Do you want to live in fear of it happening? No. Just live your life normally. You know, these permafrosts are far away from most of us. I mean, they are thawing. There's no question about that. We don't know what's in them. I don't know what we should be doing, frankly. I don't think we should be pulling out cores and looking for viruses. I think we wait for them to melt and we sample what's there. It's the best we can do. But I think there's minimal human contact with that area. The question is just whether those viruses can spread elsewhere. I'm not too worried about it. I think we have other issues here on Earth besides that. So people who worry about it, and there are people who worry. So Jean-Michel Claverie, who was one of the virologists in Marseille who has recovered these viruses, giant viruses from Siberian ice cores, he said he's very worried. And he said, I don't even want to look for eukaryotic mammalian viruses because people will say I'm being unsafe, right? But he says, I'm very worried. I'm not worried about it. I'm not worried about it. I think we'll deal with it when the day comes. H1N1, what are the H and N? H, so there are two glycoproteins. I don't have an influenza model here. There are two glycoproteins, spikes in the influenza virus particle. One is the hemagglutinin, or the H. That's how the virus attaches to cells. And the other is the neuraminidase. It's how viruses leave the cell. And when you get vaccinated, antibodies against those two proteins are pretty important for protection against disease. Yes. Did mycoplasma pneumonia catch a lipid of the infected cell when it's released? Well, certainly when it's dividing in the cell, it is getting lipids from the cell to build its new membrane, right? It's an intracellular bacteria. And so, yes, the answer is yes. Do some people clear zoster despite having chickenpox? I don't think that people clear it. I think some people just do not reactivate. But I don't see the mechanism of clearance. You know, anyway, we haven't looked at enough people to know, but I think it's there and it just doesn't reactivate. What makes it possible for the virus to remain in the host? Well, it stays below the immunological radar, basically, because if it didn't, it would get cleared by the immune system. And so only a few, so no virus particles are made. Only a few viral proteins are made. And so the host doesn't actually know that there's anything happening there. It doesn't see any virus-infected cells. So, and of course, neurons are pretty privileged also. It's a good place to hide out. You're not going to get attacked by the immune system. So, mini lecture is great and would love it to be a regular feature. I could do a mini lecture every week. Yeah, I'm starting my virology course, and I'll have plenty of material. Yeah. How is it that Shingrix suppresses shingles completely, unlike other vaccines, like COVID-19, even with the ancestral? Well, all we know is you don't get zoster, right? There's probably some virus reproduction happening, but it's neutralized by either antibodies or T cells before it can start to make the rash on your dermatome, right? So I'm not sure it's so different, right? Because it's all happening internal to us and we don't know what's going on. I mean, the COVID vaccines prevent disease, severe disease and death, right? The Shingrix vaccine prevents zoster. You don't see a rash. And it's at a very high percentage. I also think the antigen is really good. There's no variation that's happening with Shingrix. So probably those are all playing into it. Do we know why for most people they only get shingles one time? Yeah, that's a good question. Most people get it only once. It can happen more than once. I would say that you get it once and you're immunologically protected, just like getting Shingrix, right? But now you have it from a natural infection. And then maybe people who get it more than once just haven't made a good immune response. But that's my guess. Did you see Akiko say Paxlovid should be at least 15 days? So first of all, Akiko is not an antiviral expert. Right now they are doing trials at different lengths of time, and we'll see the results. But it's not for Akiko to say what the course should be. I'm not sure you need it for 15 days. We'll see what the trial does. She's making assumptions. Yikes, yes, by proclaiming this, she has a big platform and people are going to think, this is what happens when pundits start talking, okay? Someone asked Daniel this the other night. He said there's a trial going on with 3, 5, X 15 days and we'll see what happens. That's what she should say. I don't care what her opinion is about that. I like the varicella presentation. Are there viruses that in some people cause an acute infection, but in others can cause a persistent? Always these good questions always come up. Oh, let's see. Well, in some people, hepatitis C is an acute infection. It's cleared, right? I forgot the percentage, but a good percentage of people clear it, and then the remainder go on to have a persistent infection. So that's one example. And when there's one, there's more. So yes, it's a good question. I vote the mini lecture becomes a regular feature in office hours. Okay, so a mini lecture. How many slides did I have? Like 10 slides. Yeah. Okay, that's a reasonable amount. And it stimulates enough discussion. That was my point. I figured it would stimulate enough discussion around shingles and vaccines and so forth that it's worthwhile. So I would, I'll do it. Yeah. So I'll feature one kind of virus every week. You know, I'd always wanted to make a virus-specific course. I don't know if you remember, those of you who took the live-streamed virology course a couple of years ago. It was always my intention to live stream a virus course. I never did it. Obviously, this is not as in-depth as that would be, but it's the same idea. One of the reasons I had trouble getting that course going is because I couldn't decide what viruses to focus on. I can't do them all. There's so many interesting viruses. Right? So not a lot of people listen to giant viruses and virophages, but I think it's damned interesting how a virophage infects the host and protects it against the giant virus infection. I mean, this is really cool. Why wouldn't people want to listen to it? And Matthias is really good at explaining that. So I'm a little disappointed at the lack of interest. I mean, just because it doesn't infect people, really? Well, bacteriophages don't infect human cells. They infect bacteria, but people are really interested. Why? Because they think they may cure infections. So who knows what can happen with giant viruses? Okay, the mini lecture becomes a regular feature. What type of mask am I wearing? I am wearing a KN95, properly fitting KN95. What do I think of Dr. Vinay Prasad? I'm trying to think of. Yeah, he's the HIV guy. There's a bunch of Vinay Prasads. I'm getting them confused because there's one at the NCI who did some really interesting work on XMRV. And then there's Vinay, that's him. And then there's Vinayak. I don't know if it's the same person. One is at UCSF. He's a cancer guy. But I know there's a guy, Vinay Prasad, NIH. Let's look for him. Vinayak. No, that's the same guy. Well, the one at UCSF, I don't really know. And the one at NIH, I'm confusing. So I can't say Artemis, sorry. I don't know who I'm talking about. I'll be day 6 of COVID on Christmas. I think I'll Zoom the family as there are immune-compromised people attending. That seems fine. I would use it as an excuse not to go, personally, but maybe not everybody wants to do that. Anyone know if reactions to COVID vaccines indicate anything towards how an infection might be? Nope, there's no correlation. It's a totally different ball game, right? It's a different animal, as we say. I'm laughing because Alex says, what are your thoughts on bunyaviruses? Bunyaviruses are very interesting viruses. They can cause a whole variety of human diseases. Many of them are tick-borne. And we will do a mini lecture on bunyaviruses at one point and summarize what we know on them. But for example, let's see. I think they're a really interesting family. They are negative-stranded enveloped viruses. They can cause a number of hemorrhagic fevers. The arenaviruses are in them, which includes Lassa virus. The hantaviruses, hantavirus pulmonary syndrome. So A lot of interesting viruses and a lot of cool work being done on it. Do you have any advice for aspiring virologists? I sure do. I have a lot of advice. I just lost the cue here. Damn. Hold on. Okay, so there you are. Now, where are you in the big picture? Ay, where is it? Sometimes I click on a person's name and it just disappears. I don't know where it goes. All right, let me give you some advice. Read the literature. Not just the new literature, but the old literature as well, because there are a lot of gems in there. Listen to This Week in Virology. You're going to learn so much by hearing virologists talk amongst each other. And find a really good lab to work in, doing interesting stuff where the person is going to be a mentor to you and you're going to listen to them, right? Those are my advices. I was wearing a mask when I went into stores in the winter 2 years before COVID. I avoided colds. If someone asked, I just said I was sick and protecting them, like in Japan. I don't think it's a bad idea if you want to protect yourself. I never cared before, but this year these 2 rhinos just bugged me. So I don't want to get infected anymore. I mean, part of the problem with rhino is touching yourself. So, I touch the rails and stuff in trains and so forth. So I have to be really careful not to touch my face till I get to the incubator and I can wash my hands, right? Really important. So I try and do that. All right, where are we? I just lost. Weren't some companies creating air sensors to detect virus? Yes. In fact, Daniel reported on one of those not too long ago. Companies are doing that. The problem is, what do you do with the information, right? You're going to find viruses everywhere. All kinds of viruses are going to be everywhere. So what can you do? There may be more or less at different times of year, different times of day. So we can do some really interesting research like this. But then you have to figure out how to translate it into a public health policy that makes sense. And that's the hard part, because there you need to think clearly about what it is that you're trying to do. And that's the same with finding viruses in the air, which we can do. But then what do you do with it? Okay. I see that. Silvio Pina has a part 3 question, but I don't see parts 1 and 2. So like this, page 3. But where's page 2 and 1? Oh, here we go. It's way up. Oh, okay. I'm missing some others as well. Dennis, hello from Nebraska. I'm glad you like the video. Thank you very much. I don't change anything anymore here. It's just a single light, a little headlight, as you can see here on my head, and that's it. And then some backlighting. Keep it simple. KISS, right? Thank you, Dennis, for being here and for liking liking the light. In Quebec, public health recommends if you have symptoms of any kind, you stay home. If you must go out, wear a mask. How long are you supposed to stay home, right? This can be very disruptive to some people who cannot stay home. They need to work, otherwise they don't have money. So you need to figure out what to do about those people. You can't just make blanket recommendations without considering the impact on certain individuals. Yeah. What's the concerns, if any, regarding the IgG class switching that occurs in some following 3 to 4 shots? So there's a theoretical concern that the kinds of antibodies that you get are going to differ in their effector functions. In other words, the Fc portion engaging with cells could be different, but we don't know because it hasn't been looked at. So everybody got very upset about this without there being any data. So before we get upset, the vaccines are working. They're absolutely fine. There's no reason to think that this is an issue. But that's the concern, that effector functions, non-antigen binding functions might have been compromised. So bus driving, I think we should test for things, stay home if we are positive. Okay. What things? Everything? I mean, we're full of viruses, right? We're going to test for all of them. We can only test for ones that are pathogenic. How long do you have to stay home? And again, there are some people who can't stay home. Their jobs won't let them. We need to figure out how to deal with that. Maybe masking is the thing. Yeah, Paul gets really crappy comments on his blog in particular, but also on the YouTube videos that we make. People are just ignorant. You want to believe Marjorie Taylor Greene? Come on. What the hell does she know about science? Nothing. She's got a political agenda, folks. Do other viruses have a pre-symptomatic transmission phase? Some of them do. So flu has a very short pre-symptomatic transmission phase, a day or so, much shorter than SARS-CoV-2. And I'm not sure about rhinovirus. Some viruses are not transmitting in this pre-symptomatic phase. So Ebola virus does not transmit until you have actual symptoms. So it depends, right, on the virus. Giant viruses, is the small parasite virus a descendant of the piece of the larger one? No, actually, it's unrelated. Very interesting, right? It is totally unrelated to the other virus. Now, Craig, you asked a question somewhere. I can't find it. Like, how many rhinoviruses are there that I would have to worry? There are over 150. So you could get one a day. You can get many, many, many. So if you got a couple a year, you could go many years, keep getting them. So that's why you have to have some other way of preventing getting infection. Yeah. My grandson presented at UC with headache, ear pain, was given antibiotics, told to go back to school, was positive on COVID. Yeah, ear infections are often considered to be bacterial, but in fact they're viral. A number of different viruses can cause headache, ear pain. Yep, for sure. Oh, perhaps Daniel Griffin. That's not a bad idea. I could have Daniel on for an hour next week. I'll ask him. Daniel Griffin. Thank you, Lise. My experience with COVID about 8 months ago surprised me with its prominent myalgias, but almost no cough. I was in a dengue endemic area and thought I'd gotten dengue. Yeah, that would be consistent with dengue, wouldn't it? Interesting, no cough. Yep. At the Nobel Prize ceremony, they stated that public trust in science research actually increased during the pandemic. Yeah, I've heard that too, as well. It's kind of interesting, right, given all the political trashing of science? Maybe that's part of it. Yeah. Oh, sorry. Another guest would be a bacteriologist to talk about whooping cough, which is rampant in Europe. Actually, another cool person would be Jolene, right? I like Jolene. She's very incisive. I say, no, Vincent, that's not right. I like that. It's good. Thank you, Susan, for your contribution to science communication. Appreciate it very much. Yeah, we got up to 196 likes now, so that's good. With 200 people watching. And Lisa, thank you so much for your contribution as well. Really appreciate it. Here is Les has a snippet from a Brienne Jeopardy game. Go check that out. That's funny. With respect to Shingrix, it was first approved for insurance funding for immune-compromised people. I had conversations with insurance around that. Interesting. I didn't know that. Yeah, it would be the time zone would be a killer. Yeah, for Christina. All right, so JT's not worried about the permafrost virus. It's just, yeah, it is fascinating, but many people end up worrying about it. Yeah. Are there many viruses that cause multiple diseases? Yes. It depends. So, adenoviruses can cause a lot of different diseases. They can cause eye infections. They can cause gut, respiratory infections, etc. So there are, and that's not just enteroviruses as well, and bunyias. Yeah. Yep. If I got the Shingrix with the booster, well, I need to get it again. No, if you got 2 shots, original and booster, you're good with Shingrix. Yep. What happens if flu and RSV fuse? They can't. They're not compatible. They're not going to fuse. No problem. Do you have a favorite resource to learn more about phages? Here, I got a book here. We should ask Jolene, but this book is really cool. Life in Our Phage World, a centennial field guide to the Earth's most diverse inhabitants. This is such a cool book. It has maps of the viruses. It's got really cool drawings by hand. It's got explanations. It's a really good book. Okay? Life in Our Phage World. I love it. Dear Dr. Racaniello, love the show and a big hi from Mary. So that was from Forrest. Unfortunately, Mary has since passed away. Okay, that's my resource. Vincent, 2 of my 3 kids have had shingles in their 30s. Sounds like, yeah, I mean, typically kids who get shingles at a young age are immunosuppressed in some way. I know people who have been taking drugs to immunosuppress them. And I've also known people who have genetically immunosuppression, right? So either way, maybe your kids have that. Yep. Call it a snippet, perhaps. A snippet lecture. That's fun. I like that. Regarding the PWB donation doubling, in the past, have donations exceeded the doubling limit? They have. Especially in the first year of the pandemic, 2020. Hugely. But Daniel's a good guy. Well, that's all I want to say, okay? So don't worry about it. Maybe from your course, do the thing you most want general people to learn from that week's material. That's not a bad idea. I like that. Thank you. Thank you, Abdulaziz. Appreciate your contribution to science communication. Could you do an episode on MERS-CoV? Of course. Definitely. Thinking about next week also. How about Dixon to talk about his book? Greg says, when I got the old shingles vax, it cost $250 and was expected to reduce odds by 50% for 5 years. I asked a few people who had shingles if that was worth it. They all said, oh, yes. Yeah, some people get miserable shingles, yeah. Coralie, Australia, New South Wales. Got shingles when I was 30-ish, had a vaccine when I was 32, had another vaccination recently. Initially, I was told I'd only require the vaccine once. What changed? Vaccine changed. Maybe they want to update you with the new one, right? Maybe you originally got Zostavax, and now they want you to have Shingrix. My mom worked at a central supply at a medium-sized hospital in the 70s, 80s, had many needle sticks. Is there a program that monitors these old folks who have been heavily exposed in past careers? I'm not aware of any. And I think that it's usually up to the local institution to have programs that monitor that. I'm not aware of any overarching program, for example. Isn't living in a perfect sterile world actually a dangerous thing for the day you fail and actually meet something that gets... So you don't want to grow up in a sterile world, right? Bubble kids who have no immune systems, they grow up in a bubble. They're very poorly developed. Well, they have no immune systems to begin with. So take that back. Cancel that. We think that exposure to microbes as we're growing up is important for educating our immune system. So playing in the dirt, eating food with microbes in it, it's all important. Yes, you don't want to live in a sterile world, for sure. Yeah, YouTube comments are problematic. I try and not pay attention to them. I look through them very quickly, yeah. Why do hospitals and cancer centers, the places where immunocompromised people are at, don't require masks? Many of them do. Daniels does. I know that many of them do, for sure. Maybe it's not everybody. Kiko's talking about Paxlovid for long COVID. Not acute, it's a hypothesis. I understand. but she didn't say a hypothesis. She said it should be. It's not a hypothesis. It needs to be tested. Artemis says, when having a cold, how long are you infectious for? I mean, the problem with this is there's no evidence that there's any long-term production of virus that's involved in long COVID. No, there's no evidence. You need to do a trial to see if it makes any difference. And I'll bet it doesn't make any difference at all. When having a cold, how long are you infectious for? Well, it depends what virus is causing it. They can have different kinetics, right? And I don't think it has to do with sneezing or runny nose, because those can continue after virus reproduction is done because they're immune responses. So you need to go in the literature for each virus, and there are data that will tell you, for shedding of infectious virus, what's the kinetics, yeah. We have a live stream Thursday. That's tomorrow, 3 p.m. And we have a paper on the origin of modern-day bananas. Where did they come from? Always interesting stuff. Yep. I think just detecting poor air quality rather than some virus or other makes more sense, as poor air quality indicates poor airflow, which means it's easier to breathe anything there. I understand. I understand that. The price of viewing scientific articles justified? No, I don't think it. I think the luxury journals are absolutely ridiculous in what they're charging. And people are dying to get into those journals because it gets them jobs and grants and promotions. It's just all screwed up, folks. Science publishing is all screwed up. And Cell Science, Nature have messed it up entirely. They make an artificial high demand because they'll only review a certain percent of papers on a random basis, because how do they know what's important or not? Sorry, you don't know. Artificially inflate the desire to get into those journals. Oh, they only publish so much, so they must be really good. It's just a lot of garbage. So no, the price of journals is not justified at all. And you know now that NIH-funded research, if published anywhere, has to be open access from day one. I think starting this year. And that's great. But that's just U.S. federally funded research. Often saves 30,000 children a year through his rotavirus. Take that, Marjorie Taylor. Just don't go to her for your science information. With all the viruses, bacteria, phages that swarm in humans, are there any bits that are actually human? I'm sure they pick up bits, and they give us bits of their genetic information as well. Yep. All right, let's see. We got 7 minutes here. SRR, thank you for your contribution to science communication. Do you know about any self-replicating viral gene therapy that doesn't need a booster? Self-replicating viral gene? No, I'm not aware of any. Well, first of all, there are very few licensed viral gene therapies anyway, and I don't know any that are self-replicating. In Australia, there are plans to release a herpes to kill carp. No, it's not going to work. I think they already realized that with all the dead fish, there's no way to get rid of them, and so they're not going to do that. They've had problems already trying to get rid of rabbits with viruses. It just didn't work. Oh, so Prasad at UCSF is using his platform to spread nasty comments about people with long COVID. All right, so I don't know him. I know Prasad's elsewhere, so good to know that. All right, that looks like the end of your questions. Thank you so much for all your contributions tonight. Really nice session. Don't forget, go to parasiteswithoutborders.com and donate. Daniel Griffin will double your donation. I want to thank our moderators tonight. We had Les. We had Steph. Let's see if I can remember everyone. Andrew. We had Frank. We had Tom. Who did I miss? Vanity Nutrition. I think I got you all. Right? It's like 6. I pride myself in being able to remember everyone. Thank you all for moderating. I really appreciate it. And thank you all for coming. In excess of 200 people. That's pretty impressive for just the week before holidays, right? So thanks all of you for coming, bringing your questions and having a nice chat amongst yourself. It's a civilized place to come and talk about viruses and what else. And we will be back next week. I will try to get maybe Daniel or maybe Dixon. We'll see who wants to come in a holiday week. If not, you're stuck with me, and I'll give you another snippet of a lecture. Meanwhile, folks, thank you so much for coming. Stay safe. Have a great holiday. See you next week. Bye-bye.